I needed a hot air rework station, so I ordered this Aoyue 888A. So it's got the hot air and an iron with individual temperature and airflow controls and digital readout. So this came relatively quickly from Amazon, and it's time to check it out. Yeah, I really don't know how to say this. Aoyue? Aoyue? So this costs just over $100, and it's, I guess, one of the budget units. Probably mass-produced and not the best quality necessarily that you can find. So I don't want to turn this on just yet. I want to see how it's wired up and if it's safe. So before I do anything, I just want to see if this thing at least is properly grounded to start with. So continuity meter. Now I plugged in the iron, and it comes with a plastic tip, so you definitely want to remove that before trying it out. But with the iron plugged in, it's grounded, including the tip and the heating element area. And the hot air nozzle, I've installed a tip, so yeah, we get like 0.1 ohms. And I'm seeing more like 1 to 2 ohms on the main body here, but maybe because this is bolted down, it's making better contact, and I definitely get a nice ground. And an exposed screw on the side of the unit, 0.1 ohms again. So generally, the two irons and the chassis itself seem to be grounded. So I want to double check how it all looks inside, including the hot and neutral wiring against the fuse. So there's 4 screws on each side, and when you take those off, the other screws are for mountable accessories like the holders. You take it off, no problem, and there it is. So the 2 first things I see are the ground coming in on the AC is screwed to the chassis, which I already saw a good ground connection with the continuity, and there's 2 more ground wires coming off. The thicker yellow and green one goes to the soldering iron, and there's a really thin one that goes on out with all the other thin wires to the actual hot air. I don't know why this has to be so thin, but, well, something is better than nothing, I guess, with these sorts of things. The second thing I noticed, there's a lot of, looks like they put Loctite on a bunch of things, including the transformer. I also noticed this front panel circuit board. It's not really secured over here on this side. It's just sitting there. There's not even a standoff to keep it separated from the front panel. Of course, I don't expect anything to ever happen. There's no pressure that'll be on this normally, but it's still unnerving. It's not supported. Over on the other side, it kind of looks like the only thing supporting the board is the mounting feature on the potentiometers and switches. There's a couple of things I found that I don't like. Right here, there's 3 terminals, and those are the switch on the hot air output when you turn the knob to turn it on and then control the airflow. Now, the first 2 here on the left, they're not soldered at all, at least on this bottom side of the PCB. The third one in is soldered, and these, I'm not sure how they look on the other side. I think I'm going to have to take this apart and take a look. And what is happening here with what looks like a Zener diode called ZD1? The orange body with the cathode marking on the top of it. The top lead is soldered into the board, and the bottom has swung out toward the electrolytic. If it's not supposed to be there, wouldn't they have totally removed it? It's very, very suspicious, and it's a little unnerving. Is this thing safe to operate? So I've brought back the continuity meter. On this AC plug, this is the hot terminal, and this should be fused. Here's the fuse. So we have the blue wire coming to the fuse. And there's an exposed part of the heat shrink on the red outgoing wire, so probing there for continuity on the hot. No continuity. They fused the neutral. Neutral will be disconnected when the fuse blows. We will still have ground, but we'll also have hot. At least the chassis won't get live, nor the tips of any of the iron or hot air blower. A fuse is not supposed to protect neutral, so I'm going to have to rewire that. After removing the board from the front panel, a couple of things I see that I want to fix. There's not really too much wrong with the soldering on this front panel side, but on the back side of these LEDs, they left the leads kind of long, so I'd like to clip those down. Then there's this mysterious diode where the lead looks like it was desoldered and pulled up from the through hole and knocked aside next to this electrolytic, and it's just resting here out of circuit. And I didn't know, is this an accident or intentional? So looking at both sides of the board, on the bottom side I can see flux under here on the bottom of the pad. It looks like it was intentionally reheated, and just the pattern of the solder on here on the lead, it looks like it was pulled up cleanly once it was heated, and there's just residual solder there as opposed to it broke off and snapped. And the other thing is the insufficient solder on this side of the PCB for those 3 terminals for each potentiometer. There's one here and there's one here. This terminal has more solder, but it still doesn't look very good up close. And these 2 are very insufficient. They are soldered on the other side, but it still kind of looks like a big ball. It might be cold joints. So I'm just going to reflow all of these sorts of things. So now those leads are all short on the back of the LED displays. And there's no more insufficient solder on any of the pots. With the AC fuse issue, we have blue, which happens to be neutral, coming into the fuse and coming out as red. And we have brown, which happens to work out to be hot, just going straight to the circuit. And then green-yellow ground is properly grounded. So what needs to happen is the blue neutral has to be spliced directly to red neutral, bypassing the fuse, and the brown hot needs to be cut and both ends connected to the fuse so the hot gets fused. I should probably cut the tie wrap first and get this bundle free so I can work with it. I ended up cutting 3 tie wraps along this mess to give me more room to work with. I was curious what was under this existing hot wire splice that goes from brown to red, so I took this off, and I don't really like this solder joint either. It's kind of like they dabbed solder on and touched them together without twisting them or making sure the solder was flowed perfectly. I don't know if it shows up. And it's curious, it kind of looks like this was intended to go to the fuse. I don't know if these are the right length. Maybe I'll try that. It's very weird. This was the hot and looks like it was meant to go to the fuse, and they decided not to fuse it. I really don't understand the logic on this. So I'm going to separate this. I should not have been able to get that apart so easily. It should have been all twisted together. Sure, it may be functionally fine, but I'd like it to be done better. So I'll disconnect the neutral from the fuse. And now, will the hot fit? Well, look at that. The hot looks like it was meant to go to the fuse in the first place. And now it's been a few days, and the original fuse holder had a bit of a mishap. Let's just say this metal tab used to belong at the end here. The tab is no longer part of the fuse holder. So I had to go shopping. And I replaced it. So now the neutral blue wire has been spliced over to the neutral, and the hot brown wire is going off to where the hot's supposed to go through the fuse. So I put heat shrink tubing here, and the tubing was too small, so I put electrical tape here to help cover this exposed tab. And the Zener diode that I decided to leave detached, I put heat shrink over that. I might as well try to isolate it from making contact with anything. I'm going to tie wrap this bundle back together, put it back together, and finally try it out. Well, it's been another day, and I had to go take a break to get a glue gun and glue sticks. Why did I need a glue gun? 'Cause it's easy to use and bonds in seconds. This is the connector for the soldering iron. I had everything put back together and was trying it out, starting with the soldering iron, but it gave an error on the screen. Why? Well, when I unscrewed this and looked inside, the connector was recessed in and hanging toward the side, probably even shorting out on the metal. So here's the connector going out to the hot air gun with lots of hot glue on it. And I noticed there's no hot glue on this connector that goes out to the soldering iron. Maybe there should have been, because where these wires are all heat shrunk and go to the pins on this black insert that goes into the metal part of the connector and screws onto the chassis, this plastic insert with the pins was recessed into the box. So I had to manually try to figure out how to position this by attaching the soldering iron, locking it down because it screws on from the outside, make sure it's aligned and working, and now that it's all assembled, I'm going to hot glue this in place. And I couldn't really handle the glue gun while filming because of everything being in a tight space, but there's the dab of glue. I didn't want to go too crazy, especially if I ever want to undo this and fix anything. So I just wanted something that attaches to the metal and the plastic and wiring so that it'll form a backstop in case this gets pushed back in. And here's the leftover never-ending string of glue that I had to pull away from this after I was done. So can I finally get this thing put together and tested? Finally, here it is in all its glory. I like the solder spool holder. That will just sit there. Of course, the iron, the hot air nozzle, and I've got one tip on there right now with the biggest opening. And there's two smaller nozzles, a bunch of iron tips, and these forky prong things, which I think are meant for helping remove ICs, but I don't know if I'll ever use that. I just like tweezers. So the moment of truth. Main power switch, properly fused. I've already checked the grounding, it's all good. So, main power. We have a boot up message. Everything is turned off on the hot air and the soldering iron. So first I'm going to turn on the soldering iron and see that this connector glued properly. So it clicks to turn on after this main power. And as I turn the knob for the temperature, I can see the real-time setting that I'm targeting. And then it goes back to the actual temperature, supposedly, I guess, at the tip. So it's heating up to the maximum I set, and it says it's 485 Celsius. So let's see if it's hot enough to melt solder. I can feel heat, and I see smoke. Usually, especially with this unit, that's not good, but that's what I want to see. So the iron temperature went down a bit as I was melting solder. That's fine. And if I change the temperature lower, about halfway on the dial, it says I'm trying to set it at 364 Celsius, and it's cooling down from about 400 right now, going down toward the new set point. So I'll turn that off, and it's going to tell me it's off, but it's still going to show me the temperature. It's off, but it's cooling down, 353, 346, 340. So that tells me what's happening. It is at a certain temperature, but it's turned off. So I like that. And how does the hot air part work? That's really what I bought this for. So we have an airflow dial and a switch with the hot air temperature. So let's turn that on. And it's showing what I'm trying to target. Let's put the temperature to about close to 300 Celsius. So the hot air is coming out. It's reasonably quiet. And it's at 200 degrees, 230. Now, I notice this unit does not seem to have an automatic temperature shutoff when docked, unless I just don't know how to do it. I didn't really read the manual. I'm not using this really for anything hardcore, or else I would have probably bought a more professional model. I just need it to work, and I'll be here to babysit it. So it's on the minimum airflow. It doesn't look like there's a lot of opening here for air to get in, or out, as it might be. I'm wondering if I want to investigate this at some point, but for now, considering it's on maximum airflow rate, I certainly feel a lot of heat, but I'm not really hearing or feeling that there's a lot of air mass moving. I have used a different hot air station before, so maybe I'm just biased. And in the end, as long as it works and doesn't burn itself out, for my occasional purposes, that's fine. So if I turn it down about halfway, turn it back up to get an idea, it really is hard to tell that it's changed the airflow. The airflow goes from 1 to 8, and only somewhere between 4 and 5 do I actually hear a difference, and it sounds the same from 5 up to 8. So if I go down to 3, I can hear it's slower, and it just feels like there's barely much airflow difference. What if I change the temperature? I put it on maximum, so I'm targeting 485 degrees. It's at 330 and climbing. It is definitely hot. So I'm on maximum temperature and airflow. The soldering iron has stopped showing a temperature, so it must be totally cool, or cool enough. So let me dock this. Let's try to take something apart. I have an old hard drive, which happens to have the surface mount components exposed on the driver board. I certainly don't need this. It's no good anymore, so it's broken. I'm going to take some stuff off. Another good thing about using an old hard drive, it's basically a huge heat sink, so it's good for working on a non-metal desk. And the plastic handle is cool to the touch. I can hold this while working with it. No problem so far. So I put this on maximum airflow and maximum temperature of 485 Celsius. Let's see if I can get this capacitor off. It took about 10 seconds, I think. What about one of these, what looks like an 8-pin SOIC or something? Also about 10 or 12 seconds. And there's not really much on here that's connected hugely to a ground plane or anything. But what does it take to get this chip or this chip? Here goes. All I care is to push it aside. I'm not going to try to grab it. I'm about a centimeter above it. Oh, about 20 seconds to get this. And now the big one. Well, my fingers are getting hot. I don't know about the chip. Finally, it's starting to move. Oh, almost. All right. Oh, that's why it looks like it had thermal pads underneath. I was just going around the perimeter pads. I didn't realize there's thermals. So yeah, that's why I couldn't get this off. I was just going around the perimeter. This took me about a minute until I realized I should heat the whole thing. Oh, and then it popped right off. So all in all, it's not bad for the occasional hobbyist use. I can take off these parts no problem, but I don't really like the way it doesn't seem to have as much airflow as I'd like, and I'm wondering if it's because I can't get enough air in and out. Maybe someday I'll take this apart and see how this looks. Another thing I noticed, although there's on-off switches for the iron and the hot air right here, if you turn off the main power, which is what I'd be inclined to do once I'm done with the unit, it kills the fan on the hot air blower. And as you can see, it wants to blow air still. It just shut off right now, actually, because I've got it turned off, but it is still trying to purge all the hot air in the nozzle. So I actually did this earlier. I turned this off just when I was done with the hot air and it was still really hot, and the fan stopped and a whole bunch of white smoke came out of here. So I quickly turned it back on and it blew all that smoke out and then continued cooling down. So it's, again, something else just to be aware of, but again, only for occasional use. That can be micromanaged. I wish this was at the back. When I was looking inside, this cuts both line and neutral physically, but it seems more like a master switch that should be on the back, and then we just use on-off from the knobs. If it was maybe redesigned just a little bit better to account for that, so it's kind of in standby until it's done cooling down, and then it goes into a more low power idle mode rather than hard cut. Just because I don't know if there's a safety risk when you cut the main power and the hot air nozzle needs to get rid of more heat from inside. Is there a safety risk? So I'm just going to have to be conscious of that. So there it is. Finally, I don't have to use my cheap paint stripper hot air gun to take off parts brute force, heating up half of this whole size circuit board just to take off a tiny part. Now I can get a lot more targeted. It took me a week and a half, but I got it unboxed and ready to go.